Welcome to lesson 33 for college algebra. I'm going to combine the preview exercises and the demo in this video since the preview is really short. So some numbers that might be used to report the magnitude of an earthquake. They're usually like 0 to 10. Really bad earthquakes I think are like 7-ish. And no big deal earthquakes might be like 2 or 3, something like that. So we're actually going to study what those numbers mean, where they come from, and how we use them. So log functions are often used to scale very large or very small numbers into numbers that are easier to understand. So we'll look at 3 common models for log functions. In the demo, we're going to look at the Richter scale, which determines the magnitude of earthquakes. And then in the activities, you're going to look at the pH of a solution and the decibel scale. So magnitude of an earthquake. Seismologists generally determine the Richter scale magnitude of an earthquake by looking at a seismogram. So we have a little example of one here. And the Richter scale defines the magnitude M to be the log of I over S, where I is the intensity of the earthquake, and S is the intensity of a standard earthquake, which is the smallest detectable earth movement. So the 1906 earthquake in San Francisco had a magnitude of 8.3 on the Richter scale. I think that that is a really high magnitude. It would cause a lot of damage. At the same time, in Japan, an earthquake with magnitude of 4.9 caused only minor damage. So how many times more intense was the San Francisco earthquake than the Japan earthquake? So I want to compare the intensities, which is the I in the formula. So I'm going to have to figure out the intensity of each, and then to know how many times more intense, we're going to take the ratio of the two. So let's look at San Francisco. So M is the log of I over S, and I know that the magnitude was 8.3. Okay, so if I want to solve for I want to know the intensity, so I'm going to switch this to an exponential equation. So remember, there's an invisible little 10 there. And so if I switch this to an exponential equation, it says 10 to the 8.3 equals I over S, which means that I is S times 10 to the 8.3. And I don't know what S is. They didn't tell me what the strength, what the intensity of the smallest earthquake is. But so I'm just going to call it S and leave it like that. I'm going to do a similar calculation for Japan. Start out with my formula. M is the log of I over S. And for M, I'm going to put in 4.9. And now I'm going to switch to exponential form. So this is 10 to the 4.9 equals I over S. Multiply both sides by S. So I have S times 10 to the 4.9 is the intensity of the Japan earthquake. So the intensity of the San Francisco earthquake was larger than that of the intensity from the Japan earthquake. How many times more intense? Well, I'll divide them to find out, right? So I'm going to do the intensity for San Francisco divided by the intensity for Japan. So this is S times 10 to the 8.3 over S times 10 to the 4.9. My S's cancel, so that's why it didn't matter that I didn't know what they were. And now I'm dividing like bases, so I'm just going to subtract the exponents. So 8.3 minus 5 would be 3.3, but I'm only taking away 4.9, so 3.4. 10 to the 3.4 times as intense. So let's just see, what is 10 to the 3.4? Oops. 10 to the 3.4. 2,500. 2,511 times as intense, right? So no wonder that the 8.3 was a devastating earthquake versus the 4.9, which only had minor damage. It was 2,500 times as intense. So notice we could have done a shortcut, right? We could have just subtracted 8.3 minus 4.9 right at the beginning. 10 to that value is the ratio of the intensities. That's because increasing the magnitude by 1 corresponds to increasing the intensity by a factor of 10. All right, that's it for the demo. You can move on to the activities.